Welcome to Transforming Energy, the NREL podcast, brought to you by the U.S. Department of Energy's National Renewable Energy Laboratory. We're bringing you the latest in research from the lab. It's Wednesday, April 17th. I'm Karen Jerriman.
And I'm Taylor Mankel, and it is good to be back, Karen.
It's so good to have you back, and me too. We were both on a little bit of time off over the last few episodes, so thanks to Natalea for jumping in. But, I mean, this is just the dynamic duo. You know, it's you and me, buddy. We're here.
Yeah, that's right. I missed it. And I think I missed some other stuff, too. What's been happening?
Yeah, there's a lot going on these days. It feels very, very busy. Of course, something that was a really big deal nationwide, the total solar eclipse on April 8th. It was a huge deal. I got to go check out Totality, which was amazing. Did you go?
Love that. No, I stayed here in Colorado. Yeah.
Fabulous. Yeah, it was quite an experience. And not just, of course, for everyone who got to witness, partial or total. It was really a big deal here at NREL. Researchers set up a command center to monitor the impacts of the celestial event on our solar energy resources.
That's right. I was right here when that was happening, and it was an exciting place to be, even though it wasn't in totality. See, researchers saw in near real time the change in solar generation and how that reduction was managed at the regional and interconnection levels, which has big implications for how we handle the grid in the future.
Exactly. Eclipses can be predicted for millennia, right? But other disruptions come with less predictability. For example, storms or smoke from wildfires may obscure the sun across large regions. So researching the impacts of the eclipse can help us better understand that and increase grid reliability.
Always taking advantage of a good opportunity. Our researchers are putting together a full report on what we learned that will be shared later this year. Now, looking ahead, we have more great topics on tap for today's show.
Of course, we always do. We're talking very cool things happening in San Diego, like tapping into sand's amazing ability to retain heat. And we've also created a solar data tool that could expand renewable energy in Africa, Europe, and the Middle East.
I'm interested. Let's get into it.
Okay, so our first story. NREL manages this program called Clean Energy to Communities, or C2C, and one of C2C's offerings is called Peer Learning Cohorts, which includes small groups of people representing local and regional governments, electric utilities, and community-based organizations.
The groups meet regularly over the course of 6 months to learn from each other and from national laboratory experts on a clean energy topic relating to their communities.
The San Diego Association of Governments was one of 15 organizations to participate in a recent cohort. Their goal was to continue to improve community engagement around their clean energy projects.
For the cohort, they focused on 2 clean energy projects in particular. One is a climate action plan to identify actions and policies that can be implemented quickly to reduce air pollution. The other is an incentive program to support low-income households in purchasing or leasing zero-emission vehicles.
Knowing that community voices need to be front and center in these projects, San Diego's team used their C2C cohorts experience to develop community workshops and also received one-on-one technical assistance.
I appreciated having the opportunity to talk about what I was doing and how I was feeling about that work and what some of the opportunities and challenges were, and to bounce those ideas off of other communities and folks in the cohort. But I really also did find the tools and technical assistance session especially really helpful.
That was Samaya Elder, a regional planner for the San Diego Association of Governments. She said another big takeaway from the program was that it helped her to be more intentional about how she prepares and delivers presentations to her working groups and committees.
The outreach and engagement strategy was developed in-house with a lot of the learnings that I got from this cohort. So we're still right in the middle of that, but we've had 2 workshops so far that were really, I think, much different than they would have been had I not been in this cohort. Overall, I think it's opened doors to new ways of conducting community engagement, but also it's improved the things that we're already doing.
I love it. It is so neat to see collaboration and technical assistance work hand in hand to help communities achieve resilient, clean energy systems that reflect their local priorities and needs. You know about San Diego? I just love it there. I've been a couple times. There's nothing like dipping your toes into that rather chilly water after walking on the warm sand.
And if you've ever ran barefoot across the beaches of San Diego or others on a sunny day, you know that sand is very good at retaining heat, sometimes too good.
Yeah, I think we're going the same direction here with this segue, because sand's heat-retaining ability could actually help us solve some very major energy storage needs in the future.
People tend to think of batteries when we think about energy storage, but thermal energy storage could be a low-cost alternative, one where we store energy in solid particles like sand.
And anyone who feels like their shoes have turned into a total sandbox after a day at the beach knows sand can be found pretty much anywhere. It's also environmentally friendly, stable across big temperature ranges, and lower cost.
Okay, so let's break down how sand actually works for energy storage. So NREL developed a patented technology that reveals how heaters that are powered by renewable energy,
like wind and solar,
can raise the temperature of sand particles. Once the sand is at a temperature we want, it's stored in a big bin until we're ready to use it to generate electricity or process heat.
Using prototypes and computer modeling, researchers found that a full-sized energy storage device could retain more than 95% of its heat for, get this, at least 5 days.
Wow, that's incredible, considering when you compare that to lithium-ion batteries, which have 2 to 4 hours of storage. That's a significant increase. And long-duration energy storage is crucial if we want to meet our carbon reduction goals.
And since you brought up batteries, Taylor, there's another advantage of using sand. Unlike batteries, it doesn't rely on rare earth materials that have unsustainable or ethically questionable supply chains.
Right, and it's also pretty cheap. In fact, it's the cheapest energy storage option compared to compressed air energy storage, pumped hydropower, and multiple types of batteries.
Right, and it costs less than $10 per kilowatt hour. A lithium-ion battery costs $300 per kilowatt hour, just for comparison.
Wow. The big important question here. Can we just fill up a bucket of sand from any old beach and use it?
It would be nice if it was that easy, right? But the answer is no, not really. NREL researchers determined that silica sand in the ultra-pure form of alpha quartz is best for this. And that type of sand isn't really available on any coast. It's actually found readily available in the Midwest.
Interesting. Taking things back to my Midwest roots for this solution.
Yeah, that's right. And they looked at 8 different materials to determine that this Midwestern silica sand is the best material for the job.
Now that's sand-tastic. Our final story today is taking us across continents, where 20 years of solar radiation research at NREL is finally ready to advance power systems planning and solar energy deployment across Africa, Eastern Europe, and the Middle East.
Very cool stuff here. Now, follow along with us. There's a lot of detailed elements to this story. So Tanzania and Ukraine are 2 countries working with NREL and USAID. That's the U.S. Agency for International Development. And while they may exist on different continents, they face similar, unique challenges to renewable energy deployment. Most importantly, the availability, or lack thereof, of reliable long-term resource data.
In Ukraine, planners are working to find ways to rebuild and decentralize a grid that has been crippled by Russia's full-scale invasion. And in Tanzania, as is the case with many countries in Africa, reliable, detailed data has been historically difficult to access for planners and developers alike.
But that could change thanks to a new high-resolution solar time series data set tailored to the needs of stakeholders in energy sectors across national governments, academia, and private industry. The dataset lives on NREL's RE Data Explorer tool.
RE meaning Renewable Energy Data Explorer. And we've definitely talked about this very cool tool before. RE Data Explorer is a publicly available geospatial, or location-specific, analysis tool. It gives its users the ability to access renewable energy data customized to their needs.
Yes, it is a very important tool that can help inform ongoing and future analysis, policymaking, and power system planning.
And in this instance, NREL researchers looked at Tanzania and Ukraine's overlapping needs and saw how this data set could apply to both. To produce this new data set, the researchers compiled sources covering Africa, Europe, and the Middle East between 2005 and 2022.
Yes. Okay, so Taylor, you know my background is in meteorology.
Right.
So this part I'm kind of getting excited for.
Of course.
Using imagery captured every 15 minutes by the European Union's Meteosat geostationary weather satellites, NREL's partners at the University of Wisconsin modeled key factors like cloud cover and cloud composition. NREL also integrated satellite data from NASA representing aerosols, think smoke, dust, and other airborne particulates like that, to estimate the solar irradiance reaching the surface on a 4-kilometer grid. Solar irradiance is essentially the power of solar radiation per unit of area.
Very cool. NREL geospatial data scientist Galen McLaren explains it well.
The path of solar radiation is really complex. And so that's what we're modeling with the radiative transfer models. What we're most interested in is detecting and characterizing clouds. So the most important component to model for solar radiation is the clouds. How thick are they? How tall are they? What is the optical thickness? Are they formed mostly of frozen water, of ice, or are they in more of a liquid state?
Yes, cool stuff. So once they had those cloud properties, they ran them through NREL's high-performance supercomputer, pixel by pixel, time step by time step, until they had a high-resolution grid covering that 18-year period.
Here's why having easy and free access to this data is important. It helps solar developers and public utilities who may purchase electricity estimate the expected amount of electricity generated for a given percentage of years of a project. Kwame Sedgro, who is NREL's technical lead in Tanzania, said it's important to have accurate data.
Well, this is a big deal because for planning and even deciding where you want to locate plants, you need this resource data. So resource data is key. It's very, very important. And the more accurate that is, the better it is for you so that your decisions are actually taking into account what's going to happen. You can use that data set to predict what's going to happen tomorrow based on what you know from today.
Right. Okay. So going back to Ukraine and Tanzania, how does this impact them specifically?
Right. So like we mentioned, Ukraine is rebuilding its grid to incorporate more renewable energy and reduce its dependency on foreign resources. But because Ukraine is not currently part of the EU, many of the more detailed data sets for that region don't actually include Ukraine. There's a big hurdle in finding easily accessible, accurate, detailed info on the country's wind and solar output capabilities.
And part of what makes grid planning in Ukraine difficult is the diversity of solar and wind resources and potential generation.
Exactly. And with this data set, planners and developers now have a clear picture of where they can competitively build solar. It's literally making a new deployment a reality.
Which is what we like to see.
Now, over on the other side of the equator, Tanzania is also working to decarbonize its grid. By making the new datasets easy to access and freely available to the public, Tanzania and other African nations are better poised to accomplish their energy goals.
Which is amazing. And listeners, you too can check this out. Visit re-explorer.org to use the new dataset and explore the site for yourself.
Whew, what a great episode to jump back in.
That's right. Yeah, there's always something new and cool going on here at NREL. And listeners, you won't be waiting 2 weeks to hear from us again. The podcast's Lab Notes series is coming out with a new episode on Monday.
That's April 22nd. You guessed it, Earth Day, which is kind of a big deal around the lab, as one of our former directors actually helped found Earth Day.
Which is very cool. This year's theme is all about plastics. And our plastics researchers here at NREL have some plastics wisdom and awesome research to share. Don't miss that episode.
Thanks, everybody, for listening.
This episode was adapted from NREL news articles from March 2024, written by Julia Medeiros-Code, Wayne Hicks, and Timothy Meehan. Our theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by NREL's Communications Office and recorded at the National Renewable Energy Laboratory in Colorado. We express our gratitude and acknowledge that the land we are on is the traditional and ancestral homelands of the Arapaho, Cheyenne, and Ute peoples. We recognize and pay respect to the Indigenous peoples from our past, present, and future, and are grateful to those who have been and continue to be stewards of this land.